So we're still going to use these properties of logs. We have the product property, which again is when you're multiplying, we can expand it by adding the logs. When we're dividing, we can expand by subtracting the logs. And when it's raised to a power, we can multiply that exponent to the entire logarithm. So we're going to use that given some of these values. So we have log base a of 3 is approximately 1.6. Log base a of 7 is approximately 2.8. We want to evaluate the following logarithms. So I'm going to highlight a couple things here. So we know that log base a of 3 is 1.6. And then log base a of 7 is 2.8. Now I'm just highlighting the 3 and 7. So that's important because what that 3 and 7 is going to help us with is helping us to find log base a of 21. So what we can do is we're going to use the 3 and 7 to make 21 and also 3 over 7 here. And then also our 49. We can only use 3 and 7. Now the operations that we're allowed to do, so with our logarithms, is we're thinking about our properties here, we're able to multiply, divide those numbers, or raise them to a power. And some of it we can kind of combine as well. So what we can do with the 3 and the 7 is we can multiply them, we can divide, and we can even raise them to a power, and we can do a combination of that as well. Raise to a power. So thinking about 3 and 7, well, what we can do is we can multiply 3 and 7 to make 21. So we're going to write log base a of 3 times 7, right? Because log base a of 3 times 7 is log base a of 21. Now we're going to use our properties of logarithms. When we're multiplying, we can expand by adding the logs. So it's going to be log base a of 3 plus log base a of 7. Now that we have log base a of 3 plus log base a of 7, log base a of 3, they gave us a value. Log base a of 3 is approximately 1.6. So what we're going to do is substitute the log base a of 3 with the 1.6. And then log base a of 7, given to us above, is 2.8. So it's going to be 2.8. So now we're looking at 1.6 plus 2.8. So I can add it here on the side. So it's 4, bring up the 1, so it's 4.4. So we're using the properties of logs. All we're doing is we're using the 3 and the 7. Those are the only two numbers that we can use in order to make the given values here. In this case, we can multiply. So it's 3 times 7. Now notice, we're not multiplying 1.6 and 2.8. We're using the property of logs to expand it first. So log base a of 3 plus log base a of 7, using our properties of logs here, right? If we're multiplying, you can expand by adding. Then once you do that, once you expand it, then you can substitute. So this is our expanding. And then substitute with the known values and then simplify. So we have log base a of 3 over 7. So there isn't a lot that we have to do with this. Log base a of 3 and log base a of 7, they already divided it for us. So what we can do is, remember when we're dividing, we subtract. So log base a of 3 minus log base a of 7. So we subtract when it's dividing, and now we substitute. Log base a of 3 is 1.6, and log base a of 7 is 2.8. So we can subtract. So you can always subtract vertically if you're more comfortable with that. So 8 minus 6 is 2, negative 2 and 1 is 1, and it's negative. So 1.6 minus 2.8 is negative 1.2. So now let's look at log base a of 49. Again, to make 49, we can only use 3 and 7. Now, 49 is really just 7 times 7, right? There's a couple ways to represent it. So notice there's two different methods here. And so we don't need the 3. So it's not always that you need to use everything, but you have to use one of these. So we're going to use log base a of 7. So one way to represent log base a of 7 is we can say it's 7 times 7. So method 1 is using the product property 7 times 7. And so it's similar to our letter A here, log base A of 21. So what we're going to write is log base A of 7 plus log base A of 7. And then we substitute our known value, log base A of 7, they told us is 2.8. So it's 2.8 plus 2.8, and so that is 5.6. So method 1 is using the multiplication product property. And then method 2, another way to represent 49 with 7 is we can say that it's 7 squared. 7 squared. Now, using this property, the power property, remember the 2 is going to multiply to the entire log in the front. So it's going to be 2 times the log base A of 7. And then log base A of 7 is the 2.8. So 2 times 2.8, notice it gets us the same exact answer. So 2 times 2.8 is going to be 5.6. So it's whatever method that you are most comfortable with. I would say particularly you would want to use method 2 using the power property when you have like a power that's specifically greater than 2, right? If you have power, exponent of 3 or 4, it's more convenient to use the power property, but you can use whatever you're most comfortable with. So here is a set for you to try. Now there are different values, and then there's also log base b, so to kind of help you out, there are different values here. You're going to use log base b of 5 is approximately 0.9, and log base b of 8 is approximately 1.2. And so those values are different for us than the one above. So we're going to use 5 and 8. And then so you can only use 5 and 8 in order to make any of these values. So the 5 over 8, that's probably pretty fast. The 40, the 64, 125, and then the 25 over 64. So again, you can only use 5 and 8. Again, you can only multiply, divide them, or raise them to a power. Okay, those are the only 3 things you can do. You can combine them, as you'll see in this is going to be number 5 down here. You'll see that in number 5. So pause the video and try these out. All right, if you try this out, number 1, you should have gotten negative 0.3. So when you're dividing, again, you subtract the log, so you get 0.9 minus 1.2, which is 0.3. To get 40, you're going to multiply 5 times 8. Then when you're multiplying, you can expand it by adding log base b of 5 plus log base b of 8. Then you substitute. So you substitute 0.9 for log base b of 5 and 1.2 for log base b of 8. You add it together, you get 2.1. For number 3, log base b of 64, 2 ways to do it. You can either do 8 times 8 or 8 squared. And then it doesn't matter, your final answer will be 2.4. For log base b of 125, 125 is 5 to the third, so we can change that to 5 to the third. Using the power property, multiply the 3 to the front of the log, 3 times log base b of 5, substitute for 0.9 for log base b of 5, so you get 3 times 0.9, which is 2.7. Now number 5, you have to do a combination of powers and dividing. So 25 is 5 squared and 64 is 8 squared. And then remember, when you're dividing, you subtract. The numerator is the first number, denominator is the second number. So then you're looking at log base b of 5 squared minus log base b of 8 squared. Using the power property, multiply the 2 to the front of the log. Then this becomes 2 times log base b of 5 minus 2 times log base b of 8. You substitute your known values. So 2 times 0.9 minus 2 times 1.2. You get 1.8 minus 2.4, which is negative 0.6. So just for a little bit of homework help, we're looking here, we're given log base a of 4 is 0.7. And then log base a of 12 is 1.3. So in this case, we can only use 4 and 12 to make 3. And so how can we use 4 and 12 to get 3? So what you can do is, if you haven't thought of it yet, is we can do 12 divided by 4, right? 12 divided by 4 is 3. And then, so just remember using the properties of logs there. It's just like our example number 1. And number 1 is very similar to number 6. We have log base a of a third. So if we have log base a of 3, and it's 12 over 4, then we can get log base a of a third by taking the reciprocal. Meaning we can use log base a of 4 over 12, right? 4 over 12 will reduce to 1/3. Then number 5 here, we have log base a of 1/4. And again, we're only using 4 and 12. Now the fastest way you could probably think about using for this is that 1 over 4 is really just 4 to the negative 1 power. So you can rewrite this as log base a of 4 to the negative 1, and then you can just use the power property. It's negative 1 times log base a of 4, which is 0.7, and then so simplify from there. So hopefully that helps you a little bit more with those. And then 48, just to help you more, that's 4 times 12, 16. You can think about 4 squared. 64, you can think about 4 cubed. So if you need a little help, hopefully that helps you out a little bit more.